Good morning. In this video, we are going to see the petroleum refining process of crude oil to obtain various products. Since we know that we are getting the petroleum product from crude oil, that crude oil must be refined so that we can get different kind of products with respect to different molecular structure and different boiling points. Here we are refining the petroleum, that is crude oil, by the process called fractional distillation. We know that distillation is the process of purifying a liquid. Here we are purifying the crude oil and obtaining the required fuels. Here you can see the crude oil is being placed in a furnace and it is being heated. At the top of the diagram you can see at merely a 90 degree Fahrenheit, where you can get the propane, butane and lighter hydrocarbons as an intermediate products, and by having a recovery and treatment of chemical process, you will get refinery fuel gas, propanes as a final products. And likewise, in the temperature of 90 to 220 degree Fahrenheit, you will get light virgin naphtha with low octane rating as an intermediate product, and by isomerization or blending process you will get gasoline as a final product. Here this category of fuel will be having a carbon atom of number 5 to 8. In third stage, when the temperature is slightly increased to 220 to 315 degree Fahrenheit, heavy virgin naphtha will be obtained as an intermediate product, and by the chemical process such as reformers and blending, you will get gasoline, jet fuel and petrochemicals as a final products. In next stage, when the temperature is furthermore increased up to 450 degree Fahrenheit, kerosene will be obtained as an intermediate product, and by the chemical process hydrotreater, 4 final products will be obtained such as kerosene, jet fuel, diesel and fuel oil. And when the temperature is increased up to 650 degree Fahrenheit, diesel or light gas oil will be obtained as intermediates, and by the chemical process like hydrocracker, gasoline, diesel, fuel oil will be obtained as a final products, and it is furthermore heated up to 800 degree Fahrenheit. Heavy gas oil will be obtained as intermediate, and by using a hydrocracker chemical process, gasoline, diesel, fuel oil will be obtained as final products. And at last, when the temperature is above 800 degree Fahrenheit, residual fuel or asphalt will be obtained, and by using chemical process called coker or reside hydrocracker, gasoline, diesel, fuel oil and lubrication stocks will be obtained. From this diagram you can see that when the temperature is minimal, the products which you are getting will be having low carbon atoms. When the molecular structure is keep on increasing, the temperature is also to be increased to get the desired fuel. You can see the comparison. At 90 degree Fahrenheit, the product which has the carbon number of 1 to 4. It goes on increasing, and at 800 degree Fahrenheit it can be noted that the carbon atom number is up to 100. So it denotes that at lower temperature, low carbon fuels are obtained. When the temperature is keep on increasing with respect to the molecular structure, different kind of products are obtained. This is another demonstrative view of fractional distillation, where it shows that when you heat the crude oil through the fractional distillation from minimum temperature to maximum temperature, the products are obtained. Like at the time of 20 degrees Celsius, gaseous fuels are obtained, and at 70 degrees Celsius, gasoline, at 120 degrees Celsius, kerosene, at 200 degrees Celsius, diesel, and above 300 and 600 degrees Celsius, lubricating oils and heavy gas oils are obtained. The crude petroleum, as obtained from oil wells, contains gases mainly of methane and ethane, and certain impurities such as water and salt. The crude oil is separated into gasoline, kerosene, fuel oil, etc. by means of the process called fractional distillation. This process is based on the fact that boiling points of various hydrocarbons increases with increase in molecular weight. Now let us see the various chemical process involved in refining. The first process is cracking. Cracking is nothing but breaking down of large and complex hydrocarbon molecules into simpler compounds with lower boiling points. It is classified into two types: thermal cracking and catalytic cracking. Thermal cracking subjects that large hydrocarbon molecules to high temperature and pressure, and they are decomposed into smaller, lower boiling point molecules. But in case of catalytic cracking, we will be using a catalyst, that is to speed up the reaction, but it will not take part in reaction. It uses catalyst at relatively low pressure and temperature than thermal cracking. It gives better anti-knock properties for gasoline as compared to thermal cracking. The basic difference between these two crackings are: in thermal cracking, we will be using high temperature and pressure, but in catalytic cracking, we will be using low temperature and pressure, but we will be adding certain chemicals to increase the speed of the process. Next is hydrogenation. Hydrogenation consists of addition of hydrogen atoms to the certain hydrocarbons under high pressure and temperature to produce more desirable compounds. We know that the petroleum products is an organic component. Mostly it contains of hydrogen and carbon. Here we are adding an additional hydrogen atom in the molecular structure to obtain the required or desirable compound. Next, polymerization. It is the process of converting olefin, the unsaturated product of cracking, into heavier and stable components. In other words, we can call it as it is a process of making a long chained component. Next one, alkylation. It is the process of combining olefin structured hydrocarbon, that is fuel, with an isoparaffin to produce a branched chain isoparaffin in presence of a catalyst. Example, isobutylene plus isobutene is combined in presence of alkaline medium, where you can obtain isooctane. Here you can see two butylene structure, that is two molecular structure which has 4 carbon atoms are combined to form a single chain octane molecule. So, we are adding up of 2 smaller molecules and we are combining into a single long chain molecule. Fifth one, isomerization. Isomerization changes the relative position of the atoms within the molecules of a hydrocarbon without changing its molecular formula. Here, we are not changing any structure or we are not adding any hydrogen or carbon atoms, but we are changing the relative position of the particular atoms. So, the molecular formula will not change, but the relative position of the respective atoms will be changed. Sixth one, cyclization. Cyclization is nothing but joining together the ends of a straight chained molecule to form a ring compound of naphthalene family. We know that both paraffin and olefin are straight chain. In certain cases, with respect to our need, we have to change that straight chain molecule into a ring type naphthalene family. This process is called cyclization. It is joining of the ends of a straight chain molecule to form a ring compound. Next, aromatization. It is similar to cyclization except that being the product is an aromatic component. So, the basic difference between cyclization and aromatization is, in cyclization, that product or the final molecular structure may not be an aromatic component. It may be a normal molecular structure. But in this type, it should be an aromatic component as well as a cyclic structure element. It should possess the fundamental properties of an aromatic component. And last process, reformation. It is a type of cracking process which is used to convert the low antenna quality stocks into gasoline of higher octane rating. It does not increase the total gasoline volume. That is, here the gasoline volume is not being altered, rather than its quality of anti-knocking property is being increased to get the higher octane rating for better performance. So these are all the different kind of chemical process which are involving refining the crude oil to obtain the required fuel. Thank you.